Hello and welcome to this next video. Okay, so on this video what you got is um, the minimum point and the maximum point of this vertex, and this vertex is at 0 comma 3. It's a max because it opens down, and then this vertex is at 0 comma negative 1. It's a min and it opens up. So you have a got it. Why don't you pause the video and do your got it, and I'll see you back here in a minute. Sometimes we need to do a little bit more, and we need to graph y equals ax squared. So it says graph the function y equals 1/3 x squared, make a table of values, what are the domain and range. So for this, what you do is you do x, you do y, and since it's 1/3, I'm going to do easy stuff. I'm going to do -3, I'm going to do 0, 3, -6, and 6. So if I do that, 1/3 times -3 squared. Well, -3 squared, that's -3 squared is 9. 1/3 of 9 is 3. 1/3 of 0 squared is 0. 1/3 of 3 squared, 3 squared is 9, and 9 divided by 3 is 3. And then if we do 1/3 of -6 squared, that's 36. So 36 divided by 3, that's 12. And then this is going to be 12 as well. So then when I look at it, if I graph it, 0, 0, put a dot right there, -3, up 3, put a dot right there, 3, 3, put a dot right there, -6, 1, 2, 3, and then that's positive 12, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, put a dot right there, and then 1, 2, 3, and put a dot right there. Here is our parabola. It's a very wide opening parabola. And I could have plugged it into my calculator and did 1/3 x squared, but we can make this table. And then it says the domain and range. The domain is all reals because I can put anything I want in it. The domain is all reals. I can plug in positives, I can plug in negatives. That's my domain. My range, my range is all reals that are greater than 0, which means I'm never going to go below this point right here, so I'm always above the x-axis, so that's positive, if that makes sense. So you have a got it. Why don't you pause the video and do the got it. So use the graphs below. What is the order from widest to narrowest of the graphs of the quadratic functions? F of x equals -4x squared, 1/4, and x squared. So when you look at these graphs, you can see that this guy opens down, it's going to be narrow because that's bigger than 1. This guy opens up because it's positive, but the 1/4 is really wide, and this is the normal one. That's the parent function that we talked about in class. So widest to narrowest, f of x equals 1/4 x squared, f of x equals x squared, f of x equals -4x squared. That's how they go from the widest to the narrowest. Hey, you have a got it. Why don't you pause the video and do that got it, and I'll see you back here in a minute. All right, how is the graph of y equals 2x squared plus 3 different from the graph of y equals 2x squared? Well, that's, I don't know. I have no idea. But we know what I can do is I can go on my Desmos. I can go to Desmos, and I will do that right here. I will go to Desmos, and I will graph y equals 2x squared. So y equals 2x squared. And I'll look at y equals 2x squared. I believe it was plus 3. And let's look at the difference. So what do you notice about the difference of these two guys? the difference of these guys is it looks like the 2x squared is right here, and then the plus 2, it looks like it's narrower, but it's not. It's actually been shifted up. I shifted it up 2 ticks. So let's see if that's an option. It shifted up 2 ticks. Or now 2 ticks. What was it? 3 ticks? Let's see. It was shifted up 3 ticks. Because you can see that here it's 1, 2, 3. This vertex now is at 3. So it looks like it was shifted up to 3 ticks. Shifted up 3 ticks. You have a got it. Why don't you pause the video and do it? I'll see you back here in a minute. So this says as an object falls, its speed continues to increase, so its height above the ground decreases at a faster and faster rate. That's gravity. All right. So this formula right here, so this formula right here is important. This negative 16t squared plus c, that's an important formula. Gives your height in feet after t seconds. So an acorn drops from a tree branch 20 feet above the ground. That's where this 20 comes from. This is gravity. Okay, it says, what is the graph of the quadratic function? At about what time does the acorn hit the ground? So the graph, what you could do is you could plug it in, but this moves it up 20. So I'm going to go up to about right here. And the negative 16 makes it a narrow opening, but I don't really need this part. I do need this part. I'm going to stop it right here, this part, because this is the path, and this is the x-axis. That's like hitting the ground. So that's like hitting the ground. So that's like hitting the ground. So let's see what is the graph of this quadratic. What time does the acorn hit the ground? Well, what I could do, if I wanted to, I could put 0 in right here for the height, and I could do this right here. And I think we can handle stuff like this. We can subtract 20. We get negative 16t squared. We divide by negative 16. Divide by negative 16. So now we get t squared is equal to 5/4. And then we go t equals, and it'll be the square root of 5/4. What's the square root of 5/4? So the square root of 5/4 is 1.1. So it hits the ground at about 1.1 seconds. Okay? So you have got it. Why don't you pause the video and do that, and I'll see you back here in a few. So quadratic function, do you know that that's what we were talking about? Those are ax squared plus bx plus c. Parabola is the shape of the curve. Vertex is the high or low point. Axis of symmetry is that thing that goes straight through the middle of it. We learned about that in class. All right. So what I want to do is I want to keep going. I want to take a look at the next section, which is looking at ax squared plus bx plus c. And this here, your graph. This is what is the graph of the function y equals x squared minus 6x plus 4. Well, I can plug this into decimals real easy. So I'm going to go ahead and clear this out. Whoops, I'm going to clear this out and put in what we wanted to put in. So we'll clear this out and we'll say y equals, according to this, y equals x squared minus 6x plus 4. Y equals x squared minus 6x plus 4. And there it is right there. It is. So there's our graph. But what's interesting about the graph is it still opens up because the x squared a is positive. But what's different is now our vertex is right here. Our vertex is at 3 comma negative 5 according to the decimal sap. Our vertex is at 3 comma negative 5. Okay, so that's what you would want to say is that it opens up. It opens up. Vertex is at 3 comma 5. And since it opens up, it's a min. right? Now, here's what's crazy is that the uh, vertex of the axis of symmetry is found by taking negative b over 2a. If you take negative b over 2a, in this case, I'm going to take negative positive 6 over 2 times 1, so that's 3. So it's x equals 3, and as it should, because these guys should match up. And we cheated a little bit because we found the vertex, but since we know that that's the vertex, that's 3, I could take this 3 and plug it into this equation and get the y coordinate. So that's 9 minus 18 plus 4. And that should be 5. Let's see, is that right? 9 minus 6x plus 4. 3 squared is 9 minus 18 is negative 9 plus 4. And that's actually a negative 5. So it should be a negative 5, not a positive 5 is my vertex. Okay? Go ahead, pause the video and do the guide. Here we had the old one. We had this formula right here, but what we do is we match this up. This is important because the t squared is time, v is the initial velocity, and c is the height off the ground. So if you look at this, during halftime of a basketball game, a slingshot launches t-shirts at the crowd. A t-shirt is launched with initial upward velocity of 72 feet per second. The maximum t-shirt is caught 35 feet above the court. How long will it take it to reach its maximum height? What is the maximum height? What is the range of the function? What mile is the height of this t-shirt over time? So with this thing, we have h equals negative 16 t squared. The initial velocity was 72 feet. And the thing was that the initial height was 5 feet off the ground. So I have that. But if I put 35 in right here, then I have some stuff I can worry about. In actuality, I don't need this 35. Okay, I don't need this 35, but what I do need is that vertex. The vertex is at negative b over 2a, comma, f of negative b over 2a, which means I plug that in. So we want to figure out the maximum height it's going to be. So let's find a is negative 16, B is 72, and C is 5. So what I'm going to do is I'm going to find the vertex, negative B. So 72 over negative 36. 72 over negative 36. That sounds kind of weird, but what does that come out to be? Use your calculator to figure that out. If we use our calculator to figure that out, what would that be? If you use your calculator, it is going to be negative 72 over negative, I'm sorry, it's negative 72 over, it's supposed to be negative, not positive. It's negative 72. It should be negative 72 because it's negative b. So 72 over negative 32. And that comes out to be 2.25. 2.25 is the time it takes. So if I take 2.25 and I plug it into this function, if I plug 2.25 in here, I go negative 16 times 2.25 squared plus 72 times 2.25 plus 5. If I plug that into my calculator, I get a value of 86, which means that it would be 86 feet above the ground. Okay, I know it's a little rough, but we'll get through it in class. Do you know these? I do. Check what you know. Quadratic function we talked about. We talked about axis of symmetry. We know the parabola is the graph, and the vertex is the highest or low point on it. Looks like the old stuff. So I'll see you in class real soon.